All right, so let's kick it off. Hi, I'm Rachel. I'm a Kaggle Data Scientist, and this is Walter, also a Kaggle Data Scientist, who you may know as Inversion. You were the top-ranked discussion grandmaster for a while, weren't you? Or the first discussion grandmaster?
Yeah, it was kind of a funny thing when they redid. So it used to be you just had competition masters, and then they redid the ranking algorithms and broke it into competition. So they added grandmaster, they added competition, kernel, and discussion. And so when they did that, I was like by far the highest, had the most discussion points, so forum upvotes, and so I was the first and only discussion grandmaster for quite a long time, which is kind of funny. I mean, kind of salty too, because it's like I wasn't a competition grandmaster, but I was a discussion grandmaster. So for what it's worth, hey, the community was, by far my favorite part of Kaggle anyway. So, I was actually proud to have that grandmaster title.
Yeah, it's an achievement, definitely. And as someone who enjoys talking, I think you're a great first competition data scientist to join me. So this is Kaggle Coffee Chat. I actually don't have coffee. I have tea. So it's poorly named. Do you have a beverage, Walter?
So I usually don't like to drink things that are hot. This is my Monster Energy drink of the day. Most Kaggle competitions that I launch are unofficially sponsored by Monster Energy, so hey, they help.
Wow.
So for those who don't know, I actually live in Wisconsin. I woke up this morning and it was -7 degrees Fahrenheit. So what better than a cold drink to
just really drive it home that you are enjoying your frigid weather.
It feels like a warm drink, actually, just with things relative, but yes.
That's fair. That's fair. You can drink it, so like comparatively, it's pretty warm. Yeah. So just to kick it off, what are you working on right now?
So
that you can talk about publicly.
I am working on So that's the other thing. So what's fun about this job is it's just like with Kaggle competitions. There's always new things coming around in the pipeline, so we get to work on all sorts of fun things. I particularly, like at this moment, I'm working on 2 competitions that are from repeat sponsors, sponsors that have hosted competitions in the past and are coming forward with a new one. And one competition was extremely popular last year. It was an NLP type competition, and it's going to be a little bit different. And the other one is a multi-label classification. So both of these are going to be new metrics. The one is going to incorporate more of a fairness type metric. So for people who are interested in algorithmic bias, this will be a really, really, really fun competition. And the other one is actually going to be a new multi-label classification metric. So
yeah, exciting. Have you been following? I think the Fatstar Conference is like, it's coming up. It might even be happening now. Have you been following any of that?
I don't follow that closely. I try to stay up to speed, but I don't necessarily deep dive.
Yeah, it's January 29th through 31st, so next week. And it looks like it's actually going to be live streamed as well. It's an ACM conference. So it's FAT, fairness, accountability, and transparency, and then like a little asterisk. So.
Is this in Montreal, if I remember?
I'm on the webpage. I don't see it in the first like 2 seconds of looking at it, so I guess we're just never going to know.
Yeah, there's a lot of nuance and subtlety to get these things right, and I expect that we'll have more of these type of Kaggle competitions, and that we'll learn a lot, right? Anyone who's done any amount of Kaggling knows that part of it is the learning process, right? Figuring out how do you pose a competition so that it's worthwhile, it's fun, there's not leakage, the metric, it doesn't get pathological in certain cases, and yeah, I assume we're going to learn a lot with this one.
Yeah, so do you want to talk a little bit more about the process that you take for developing a metric? Because I know that that's something that like most professional data scientists in their job would do for themselves, and at Kaggle, people get to benefit from your good work.
Yeah, the reality is I did an analysis once, and I think like 60 to 70% of our competitions, a very large percent of our competitions only use, I think it was 4 metrics: log loss, AUC, accuracy, and maybe math at K or something like that. So we generally try, if at all possible, to keep metrics on ones that are established. And the reason is because people understand how AUC works, right? There's advantages, disadvantages, but they understand that there's the models know how to optimize to that. So if you do a brand new metric, all of a sudden, XGBoost, which needs a second derivative, now people have to figure out, okay, how do I make how do I incorporate this custom metric so that it's optimizing? So a lot of people just optimize to AUC anyway, and then hope that improves the XYZ metric. But there are plenty of cases where we need, some sort of custom metric. And, that is often takes longer than the data prep because of the things like, so we want to make sure, obviously, have plenty of test cases so that, we don't find these weird edge cases where the metric goes pathological, making sure that it's not gamed at all, right? So a lot of times we have sponsors say, well, we want to weight certain things more than others. Then it turns out that, like, if you focus your model all on that certain thing, then the others don't matter. So getting that balance right. Yeah. But so because the Kaggle platform is a lot written in C#, our metrics are written in C#, so we kind of like mock it up in Python, make sure it works great, and then we kind of translate it to C#. But then we also have to make sure that it scales well. So we've had competitions. No one likes to wait 8 minutes to see what their score is, so we try to also optimize.
Yeah. So what's a good example of something going pathological?
Yeah, so it's almost always, we've had a lot of problems with masking, where, like if how pixels are handled on the edge. So and the reason being, you have to translate it to like a run length encoding, but then depending on how you index that run length encoding, it can screw up and not have enough pixels. So then you get all sorts of errors, and or the results don't work in a trivial case that you would expect it to. So we do a lot of testing, make sure at least the trivial cases work.
So it sounds like it might be more of a computer vision, or you find it more often in computer vision. I guess you get more computer vision competitions because that's more your background.
Well, the more, so I know I don't have a background in computer vision.
Oh, I thought you did.
No.
Didn't you do like spectrography stuff? Am I just making things up?
So I'm a chemical engineer. So a tangent. So really quick. So my background, yeah, I have a PhD in chemical engineering, and my work was in turbulent two-phase flow. So how particles preferentially concentrate in turbulence. So think like water particles in the atmosphere, or like even bubbles in the ocean or whatnot. So yeah, that's where my expertise was. So yes, there is a lot of spectroscopy in chemical engineering, but no computer vision.
Oh, interesting. That seems like, to someone who does not know a lot about computer vision, kind of an obvious application.
Oh yeah, absolutely. There's like literally so much opportunity in industry and the sciences to apply this type of thing. I mean, it's just crazy how much like opportunity there is for the taking. The challenge is a lot of the industries that have manufacturing is a great example, a huge data set. There's manufacturing where they're like, imagine consumer products, and they take a snapshot of every single image, and it's usually very simple type of, does it meet measurement specs? But you can imagine there's so much vision recognition technology you can put into that.
Yeah.
But the problem is most of these industries also don't have, like, the talent is going in the fintech sector or the tech sectors, and so there's these traditional companies that have the data, could use the data, have a hard time attracting the talent.
I can see that.
And even somebody like, I know you're an NLP expert, but you think about, there are companies that literally pay people to read all of their Amazon reviews and read all their social media, and then they like write a summary report where, think how much of the sentiment can be automated.
Yeah, absolutely. Yeah.
So back to the metrics. So the metrics,
the
more complicated. We've had some of our autonomous driving metrics have been thousands of lines of C# code because they're just very, very complicated, right? Those are the ones that just because, right? Just intrinsically, those metrics can be just hard to understand, like what's actually happening. And we've found experts that have come with us, here's the metric that we're using, and found errors in like what their paper said versus what they've implemented.
Yeah, especially like modeling super complex processes where we may not have like a super good understanding of how humans are doing this task. Like, how do you make sure computer do good?
Right. Yeah. And a lot of sponsors that come to Kaggle don't necessarily have a well-defined business problem. So they kind of say, well, we want to kind of predict better. Well, so when you talk to them, they don't necessarily have a good way. So a lot of the job is actually helping them understand why you may want to use one metric versus the other, even though they're used to reporting on this metric. This one will give them better results, or sometimes that they want this pet metric, but you can show them, look, you're not going to get any different results if you use this metric. So we'll kind of guide them to a metric that is more common in the for the Kaggle competitions.
Yeah, easier to like slot into existing algorithms. Yeah, I can see that.
So back to the chemical engineering thing. I love the competitions that we get on Kaggle that are more physicsy based. So we've had like the CERN, we've had the plastic astronomy that take what are traditional science problems and add a layer of machine learning on top of that. To me, those are some of the most fun and rewarding ones. They don't have as much participation because rightly it takes somebody who's interested in that, but the people that do participate really come out of there with kind of like very worthwhile activity for them.
Yeah, and it's sort of like what are the words I'm looking for? Like expanding the horizons of human knowledge. And I don't know, we both did PhDs in the sciences. Clearly, like in our hearts, we're like weird idealistic nerds who are like science for science sake.
Yeah, one of the winners of the recent astronomy competition has like zero astronomy background. So it's neat that people in other domains can come to Kaggle, machine learning experts, and move the needle on some complicated questions.
Yeah, absolutely.
So that's what I'm working on currently, and hope to have those. Those two will be launched in February and March. So still a couple of months to get those done.
Something to look forward to. Yeah, I'm always excited to get a couple more NLP competitions. I feel like it tends to be, as someone who is more interested in NLP than computer vision, every time there's a new computer vision competition, I'm like, ugh, but it could have been on text. So.
Yeah, text is fun. I can, do the basics. It's what's neat about that is you can do a few lines of code and actually not get a bad score at all. It's how quickly you can do some good stuff, but then it just gets so complex and nuanced. It levels off really quick. So it's very rich problem space. Yeah,
absolutely. Language is hard.
I don't know if you saw that, right? Anthony Goldblum is at the Kaggle Days competition in Paris, and somebody who I think won the Jigsaw last year. The way he created additional data, synthetic data, is he would take the sentence and he would put it into Google Translate it into a language, and then translate it back to English. And there was enough little variability in what came back that basically he was creating synthetic data, and I thought that was very clever.
Yeah, interesting. Because if you do like augmentation by like flipping text, that's nothing. That's not helpful. That's not language anymore. Yeah, that's really clever. I like that. So speaking of clever things, have you read any papers or blog posts recently that are just like, ooh, very exciting?
Yeah, absolutely. So I see you've been on a BERT kick lately.
Yep.
Okay, so I've been on a Murph kick.
Murph, M-E-R-F?
MERF.
Mm-hmm.
So one of the things I do, I mentioned that YouTube is by far the medium I go to most. So I follow all of the PyCons, the SciPys, the PyData, right? I subscribe to them, and is the
Our studio conference?
Yeah, absolutely. As those are posted, I go through and kind of like triage, which I want to watch later. But there was one it was the PyData LA 2018. The presenter gave a talk on mixed effect random forest. And for those who maybe aren't familiar with that, the classical example is if you want to model like student performance. So you may say, all right, I want to, say, okay, by teacher, and maybe then have a school effect, and then maybe a district, and maybe a county and whatnot. And so you don't want to create a model for each teacher because you miss the larger global, maybe a statewide effect, and you don't want to ignore the teacher effect. So you can have these effects. Now, so if you have a parametric model like a Bayesian hierarchical modeling is kind of the classic, right? You can put this together. So how do you do it if you wanted to do a random forest?
Yeah.
And there are Kaggle competitions where it makes sense to do this type of clustering, like the Rossmann, where you wanted to predict sales at different stores, and it was in Germany, so you had these store sales, but then you had the day of the week effect, and then you had the store, and then you had the region in Germany. How do you do that with a like a non-parametric model? And so there was a paper that came out a few years ago, and then these some people from, let's see, it was where are they from? They were from Manifold.ai created this Python package that actually allows you to create have an effect, whether it be like the store or the school or the teacher, and then there's all this cool math that happens. So I have not actually done much other than installing the library and doing some simple things, but I'm actually really interested in plugging it through some of the historical Kaggle competitions that have this natural clustering of store effects or hierarchical effects or longitudinal effects.
Yeah, I'm actually interested to, because I haven't heard, I'm not saying there isn't one, but I haven't heard of an R implementation of this. And I'm surprised, because this seems like core, like statistics, like I would go right into R. And I'm going to be honest, the mixed effect modeling Python libraries are not as polished as the R one. So I tend to use R for my mixed effects regression, at least. But yeah, that's really interesting. I'm going to have to look into that.
It was funny because I was looking at the issue log, because they really do. This needs a lot of work. And one of the first top issues is somebody's asking, hey, has anyone done this in R? So it's kind of an obscure paper. This group found it because they work with clients, they implemented it. It needs a lot of love, but it's one of those things where it could be, and what's cool about it is it doesn't necessarily to be a random forest. You can put in any type of, well, theoretically, right? You have a random forest, but add a boost or, gradient boosting, you can put in any type of estimator and have the same mixed effect.
Yeah, sort of any cart.
Yeah. So yeah, that's kind of the thing I've been toying around with, and I wish I had when I was actively competing.
Yeah, absolutely. I actually could have used that in my dissertation because I did mixed effects modeling and I also did conditional inference trees. But I would have been nice to bring them together.
Yeah. It turns out the math. I mean, I tried to figure out, like, I thought really hard, how could I do this with XGBoost or whatever, and I never could figure it out. Turns out the math is way more complex than one might expect, which so kind of made me feel better that like it wasn't some obvious answer on what you need to do to make it work. Yeah,
no, that's really interesting. I hadn't heard about that. I'm gonna have to ask you for the link for that to take a look.
You bet. You bet. I will do that.
Thank you. And is there anything else you want to share with the Kaggle community before we wrap up?
Yeah. So one thing I want to kind of plug. Every once in a while, so a lot of people know we have like an in-class version of Kaggle. So university
Okay, in class, one
in
word.
class, yes. Create like little mini Kaggle competitions for their, a class. And many universities do that. So like as a final exam, they'll put some data and the students basically have to do a mini Kaggle competition. And there's the Tampere Technical University out of in Finland. Every year they host an open in class, and it's always very well done, and it's always very interesting. And what they do is they open it up to anyone who wants to participate, and they encourage Kaggle masters, grandmasters, anyone that wants to participate, and as well as the class. And then they have so the one is robot surface. So it's if you just Google Kaggle.com and then look up robot surface, and the idea is they had these little autonomous robots that they drove around the university, and they had various like inertial accelerometer, whatnot sensor, and they collected the data depending on what surface it was on, like a wood floor, a tile, a carpet. And so based on this accelerometer and inertial data, predict what the robot was driving on. So it's a fun little signal problem. Look it up if anyone wants to, learn more about feature generation from signals. And it's a very, very approachable problem and a lot of fun. So that's going to be my plug for people to check out.
Yeah, when you said robots, I was like, oh, it's going to be something with agents, but that actually does sound interesting and fun to me as someone who is less interested in agent-based learning.
Yeah, no, right. It's very simple. It's kind of analogous. So there's a great data set on Kaggle where they took a smartphone and they attached it to somebody, I don't know, where they, like maybe on their arm, and then they had the person go up the stairs, go down the stairs, lay down, sit, walk, and then based on the smartphone, the gyrometer, the accelerometer, predict what activity they're doing. So it's the equivalent, but for a robot. Yeah,
that's really interesting. I feel, wasn't a smartphone one somebody's dissertation data?
I believe it was. Yeah, it's a fantastic data set too. What's neat about that one is, at least the one I saw in Kaggle, it was almost 2 years ago, they had done all the feature generation. So you don't have the raw data. So if you have signal data, you can like see all sorts of ways you can take a signal and extract, features from that.
Yeah, that's really cool. I have other things to do right now, but now I'm all like, oh, I kind of want to go and play around with these things.
Yeah, my list of things that I want to do, that it grows much faster than what I actually end up doing.
I know, especially in machine learning, it's just like there's so much constantly coming out, and you're like, that's cool, that's cool, that's cool, that's cool. I don't have time for all of this, but I want to have time for all of this. Constant struggle.
And the other thing I'll share, especially if anyone who is new to Kaggle or new to competing is watching this, my first Kaggle competition, I was so confident that I was going to do well. There were, I think there were, what were there? I have it pulled up. There were 236 teams, and I thought I was going to crush it, get the $25,000 prize, and I came in 22nd from the bottom out of 236 teams, and I was trying hard to win. The only people that did worse than me, I don't think were actually even trying. So, like, there are some people that don't do well in a Kaggle competition and kind of says, "Oh, this isn't for me." I was there. Just keep trying new ones and learning and getting better every single time, and you'll eventually get to a point where you're in the top 25 and then the top 10% and then the top 10. So just keep working at it and learning new things about machine learning, because it's not going away. So it's really worth your time and your investment.
Thank you, Walter. That was very inspiring.
Thank you.